All right, here we are, quarter 4, week 2, day 1. We need to solve a subtraction problem and an addition problem. All right, so let's go ahead and solve it. We do have decimals, which means we have to line up the decimals. So we have 94.2, and then we have to put a 3 here, the point there, the 8, and the 9. Subtract it. All right, we have to put a 0 right here. We cannot take 9 away from nothing, so we're going to have to borrow from this 2 and make it a 1. So this becomes a 10. 10 minus 9 is 1. We can't take 8 away from 1, so we're going to have to borrow from the 4 and make it a 3. This becomes an 11. Well, I zoomed in 11. It becomes an 11. Things taking its time today. 11. So we have 11 minus 8 is 3. 3 minus 3 is 0, and 9 minus nothing is 9. Bring down the decimal. 90.31 is our subtraction problem. All right, so let's go ahead and do this addition problem. Once again, we're going to have to line up the decimals. We have 4390.2. Then we have to put 57.304. So we lined up the decimals, which means we're going to have to add some zeros here. 4 plus 0 is 4. 0 plus 0 is 0. 3 plus 2 is 5. The decimal comes down. 0 plus 7 is 7. 5 plus 9 is 14. 1 plus 3 is 4. And 4 plus nothing is 4. Put the decimal there. Go over 3 places. We have 4,447.504. All right, there's our answers for those two. All right, it says fill in the blank, and we have 55 decimeters, and we want to know how many meters that is. So right down here I showed that 1 meter is 10 decimeters. Well, we want to try to figure out what is the relationship between these two numbers. Well, if we take 55 and divide it by 10, then we know that that 10 times 5.5 is going to give us 55 decimeters. So whatever we do to the bottom number, we have to do to the top number. Of course, we're going to multiply that by 5.5. And 1 times 5.5 is 5.5. So we do know that 55 decimeters is the same as 5.5 meters. Okay, that's all we have to do for that problem. What is the value of 8 to the third power plus 5x when x equals 12? So we just have to replace all of the x's with 12. Well, there's only one of them. So we're just going to rewrite this. 8 to the third power plus 5 times 12. And there's lots of ways I can write 5 times 12. I just like to do it that way. All right, so we have to do order of operations. We don't have any parentheses other than this 12. And there's nothing to reduce in that because it's just the number 12. Then we have exponents. So we have 8 to the third power. I guess it's 8 times 3, right? No, it's not 8 times 3. It is 8 times 8 times 8, which equals 512. So we have 512 plus 5 times 12. Okay, so the next thing we want to do is the 5 times 12. So 5 times 12 equals 60. So we have 512 plus 60. So the only thing we have to do now is just add 60 plus 512, and that gives us 572. So the answer is 572 when we put 12 in for x. List 3 values that would make this inequality true. We know it's an inequality because that's not an equal sign. That is a greater than sign. All right, so we have to find out what y is, okay, if we can get it by itself on that side of the inequality sign. So we're going to rewrite this. 180 is greater than 15y. And we have a 15 and y right together, which means that is multiplication. So what's the opposite of multiplication? It is division. So we're going to divide both sides by 15. Okay, and if we do that, we're on this side, 15 goes into 15 once, so we're just left with 1y. Again, I could put a 1 in front of the y, but that's kind of unnecessary. And then on the other side, we're going to take 180, and we're going to divide by 15. And that gives us 12. So now it says 12 is greater than y. And I have a thing where I always like to make it so that the variable is first. So I'm going to rewrite it. Instead of saying 12 is greater than y, I'm going to flip everything over, put the y on the left side, change the direction of the sign, and put a 12. Because in my mind, I can really clearly understand when I say y is less than 12. I know that it could be any number that is less than 12. So in this situation, can it be exactly 12? No, it can't, because it doesn't have that little equal sign on the bottom of it. Y is less than 12. So we cannot put 12 as one of the options, but what numbers are less than 12? Okay, 11, 10, negative 40, anything like that. So any number that is less than 12, you can put in these three spots, and that will give us our answer. So those, any three values that are less than 12, that would work for the answer for this inequality. All right, now we need to find the volume. All right, remember volume is always length times width times height. So we have 10 1/5 times 4 1/4 times 2. All right, so let's go ahead and start making this so we can actually work with them and change them from being a mixed number to an improper fraction. 10 times 5 is 50 plus 1 more is 51. So this ends up being 51 over 5. 4 1/4. 4 times 4 is 16 plus 1 more is 17. So we have 17 over 4 times, well, the 2 becomes 2 over 1. Is there any cross-reducing we can do here? There's a little bit. We can divide 2 into 2 and get 1, and divide 2 into 4 and get 2. And there's really nothing else we can do. So that saved us maybe a little bit of work later. All right, so we're going to have to do 51 times 17, and that's going to equal 867. All right, and then we're gonna have to do across the bottom here 5 times 2 times 1, which is just 10. All right, so then we're going to take 867 and we're going to divide by 10, and we know that that would go into it 86.7 times. So we know it's 86 sets of 10 will go into 867. Okay, so if we take that, it's just going to be 860, right? 86 times 10 is 86 times 10 is 860. So we have 7 left over, right? So we're going to have 7 on the top out of 10. So we have 86 and 7/10. We can't reduce the 7 over 10, so that's our answer, 86 and 7/10. And it's going to be in inches, because we're doing volume. Inches what? Inches squared, inches cubed. It's going to be inches cubed, right? Volume is always inches cubed. So 86 and 7/10 inches cubed. Draw a line plot to correctly display the data. All right, so here we go. Here's our data. We have a 4, 5, 6, 9, 13, 14, 14, 14, and 15. There's our data. So let's go ahead and plot that. How many 4s do we have? We have 1 4. So I'm just going to put 1x there. We have a 5, so we're going to put 1 there. We have a 6, so I'm going to put 1 there. We have a 9. We don't have a 7 or an 8, but we have a 9. So I'm going to put 1 there. We don't have a 10, 11, 12, but we do have a 13. And there's just one of those. We have 3 14s. So we have 1, 2, 3 14s, and we have a 15. Okay, so we've made our line plot. That's all you have to do to make a line plot. Make sure you have a line that has the lowest number on it up to the highest number on it, and then plot them. Okay, so now we need to find the mean, median, mode, and range. Remember, guys, the mean is the one that you add them all up and divide however many numbers are in the data set. The median is the number in the middle. All right, so let's find that one. So let's cross out on each side until we get to the middle. There's 4 crossed out on each side. Okay, the only one left is 13. That's the median. Okay, that's the number in the middle. All right, so let's go ahead and move this out of the way, and let's look for mode. Well, mode, we can look a couple different ways on this. we can look down here and see clearly that we plotted 14 more often than any other number. Okay, or we can just look up here and see that it's more often than any other number. So the mode is 14. Now the range is the difference between the highest number and the lowest number. So we just subtract 15 minus 4, and that gives us 11. Right? And then the last thing, and usually what takes the most time, is the mean. So we have to add them all up first, okay, and then divide by how many numbers are in the data set. And remember, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers in the data set. So we add them up and divide by 9. All right, so here we go. 4 plus 5 plus 6 plus 9 plus 13 plus 14 plus 14 plus 14 plus 15, and that equals 94. So we have 94, and we have 9 numbers in the data set. So 94 divided by 9 is going to be 10.4. Actually, it's 4444 repeated. So we'll just leave it at that, 10.4. So it says, what is the best measure of center? Well, it kind of looks like, in this situation, the mean is going to have some weird skewed situations because you have numbers way down here and you have numbers way up here, and then you have all kinds of like sporadicness. As a matter of fact, if you get data like this, it just means it's not that good of data. It's just too sporadic. But nevertheless, if this is what we have, we would probably want to choose the number in the middle. So we would probably want to choose the median. Okay, so if it's not the mean, you would want to choose the median as the best measure of center. So we'll just put median. Okay, so we found the mean, median, mode, range, and we think the median is the best measure of center, and we plotted the line plot. So we did a lot in that box, and it's all finished. Use the box and whisker plot to answer the question below. And the question they want to know is, what is the interquartile range? Okay, so there's, remember, the 5 things that you need to have a box and whisker plot is the highest number, which obviously in this data set is going to be the 16, right? Right there is where the highest number is. The lowest number is going to be on the opposite end, and that one is what? Yes, it is the 8. Okay, so 16 is the highest number in the data set. So if there's a whole, we don't even know what the data set is, but we know the biggest number is 16. And we know that the lowest number is 8, right? So that's the highest and lowest number. So to find the range, you just do 16 minus 8. But they're not asking for that. They're asking for the interquartile range. Okay, so remember the number that's plotted here is the median. So for whatever data set this is, the number in the middle is 13. So that is the median. Okay. And then remember, at that point, we take the data, we slice it in half, and we find the median or the middle number of the upper half. Okay, and that would be the upper quartile. Okay, and then we take the bottom half of the numbers, find the middle of those, and that becomes the lower quartile. So to do the interquartile range, it's going to be 15, because that's the middle number of the upper half of the data, and we're going to subtract 9 because that's the middle number of the lower half of the data. So we have 15 minus 9, and that equals 6. So our interquartile range, which is abbreviated IQR, is 6. So 15 minus 9, that gives us the interquartile range. All right, that's all we have to do for this one.